talking a lot, so just let me know if you can't hear me, and I'll try to raise my voice a little bit. How many here are from actually the Bridges program? Just a little show of hands. Engineers? All right. All right, well, hopefully I'll convince everybody in here to stay in engineering and also convert all of the rest of you to engineers. This presentation is it's not going to be a technical presentation. I'm actually here to try to recruit you all and get you to think about your career, your future, and possibly having that in Tallahassee. As he said, my name is Tarik Dickens. I graduated with my PhD actually last year in 2013 in the Department of Industrial and Manufacturing Engineering at Florida State, Florida A&M University. We'll talk about more about our program and some different things within that. So my presentation is actually entitled Why STEM in the State of Manufacturing, and more emphasis on the engineering and more emphasis on manufacturing and where that can take you as far as your careers in the future. So this is actually a satellite photo that was taken from the International Space Station last week. You can see Florida pretty clear here. Here's you guys down here, Valencia Community College, Valencia College, and then also me up here in Tallahassee. So we're not too far away. It's only about well, for me it's like a 3-hour and 30-minute drive. Most people it's like a 4-hour drive. So we're not that far away. You can always come back and visit your family. Come back and go to Universal Studios or Disney World, since everybody here is probably go there every week, right? So we also have a beach down in Apalachicola that's less than an hour away. There's also St. Mark's, St. George Island. So if you like the beach and want to have a little fun in the sun, you have that opportunity as well. And then something else I want to point out is Tallahassee's pretty safe. We never have any hurricanes. All the hurricanes usually sort of divert in either direction. And the winters are pretty mild, so there's all sorts of things that you can do, and then you're also close to other places and states that have different activities, since everybody likes to be busy and do other things. So I want to ask you guys a question, and I actually like to be interactive. This is kind of how I am in my class as well. I like to have everybody have a good discussion and talk about it, but how did we get here? And of course this is a rhetorical question. But how did we get here? I see we got the same watch, right? Yeah, cool watch. You like it? Yeah. He's videotaping. Has a videotape on his cell phone. Everybody here is wearing clothes, right? Driving semi-nice cars. We can afford them. So how did we get here? We have lights on in the building. Projector on the screen. Well, you guys aren't that quiet in class, are you? None of them are. I know. The same everywhere. Anybody? How did we get here? You just scratched my whole presentation. Combined effort, right? A lot of people working together. Well, I mean, if you look at the last 100 years or so, it's really a couple of events that have really opened technology up for everybody. And not just America and the things that we've been involved with, but the world as well. I mean, you had the Industrial Revolution, which started way back in the 1600s, all the way to World War I, World War II, with the Manhattan Project, space exploration in the 1960s, the computer chip, which is one of the greatest achievements as far as humankind, right? What's so special about the computer chip? About the transistor? Anybody know Moore's Law? So the more chips that you can fit, right, it just exponentially increases your computational power rate. And so that's how we can have these cell phones that are, a couple millimeters thick, right? And then also now, the last couple of years, the information revolution, right? Information is readily available. Anybody in any place. If you have internet, right, you can learn about advanced physics, chemistry, all this stuff. Not that you don't need to come to school though, but information is just, it's so available to us. So my question to you is, what's on the horizon? Since I asked you a question, I'm going to ask somebody else a question. What's on the horizon, sir? What's your name? A Rose? Roosevelt. What's on the horizon, Roosevelt? So I'm somewhat of a futurist, so I always like to think 100 years in the future, even a couple hundred. Yes, sir. Give me your name first.
It's Stefan.
Stephen? Nice to meet you, Stephen.
Nice to meet you as well. What about living on another planet?
Living on other planets. Man, you guys are stealing my presentation. Cutting it in half. Living on other planets is a possibility, right? Well, the question is, how are we going to get there? So, on the horizon, that's the future, right? And for me, I was born in the 80s, so everything back in the 80s was about, something on another planet, whether it was Voltron or, watching Star Trek or Star Wars. So, yeah, this is eventually where we're trying to get to, though, right? In order to get there, though, we're going to need a lot of effort from a large community of different specialties. So for me, like I said, I'm part of the 80s, so to me, this is the greatest achievement. This is where we're trying to go. Everybody knows this is the Death Star, right? And then you also have the Starship Enterprise. So for us to actually be able to even build something like this, you have to have a whole group of people who want to learn about science, want to learn about the stars. Not just the stars, but think of it, biology. All this stuff comes together to create this opportunity for us. So a lot of times, movies that kind of, they're leaps and bounds beyond as far as the science and the technology of our day. But they still give us, that glimpse of where we need to go in the future. So, again, this is really attainable through everybody here, which everybody here can have a part of this future. I mean, I think everybody in here is around 20 something, right? A little less than that, maybe. So I'm kind of old, so I'm out of touch. Who's the youngest person here? Anybody here 18? Oh, got some babies in the house. But your generation is going to be the one to make this happen. And that's why all of you are here, right? You want to be part of something that's greater, not just yourself, but you want to contribute to your communities, to your families. So this is how we do this, through research and going to school. But really, this is more realistic. It's not as sexy, right? But if you go from, a machinist to a designer, this is somewhat more practical, right? This is actually called the Nautilus X115, which is one of the concepts for a deep space exploration. So yeah, this is more reasonable right now, but who knows? We might get to something this shiny that we all see about when we go to the movie theaters. So my outline for today is really, I already gave you my pre-introduction, which is what's on the horizon. But I'll talk about a little bit about industrial engineering, manufacturing engineering. We'll talk about the state of manufacturing engineering, and I'll give you some view of what's offered at FAMU and FSU. And then also we'll talk about some off-the-record stuff. And because I am a professor, I always have to give a test at the end of the lecture, so I'll give everybody here a test. But I'm sure you'll all pass, so you don't have to worry about that. Everybody know who's this person right here, right? I mean, who is this person? No? Okay, you can get an F for today. Somebody help him out.
Albert Einstein.
Albert Einstein. It's actually right there. You always got to pay attention. You got to pay attention to the fine details. I mean, this is Albert Einstein. He's probably regarded as one of the greatest minds that may ever will be. Guess what? He's actually a failure. Anybody know why I say that?
Dropped out of school.
Did he drop out of school? Something close to that. He actually got an F on his first calculus class. What does that mean? What does that mean to you? Yes.
The teacher
teacher, you think the teacher can understand his work? Is that your problem? It's always the teacher's fault. It's always the teacher's fault. Actually, Einstein would have told you, he wasn't a good student. But guess what? He's regarded as one of the greatest minds ever. Why? Because he never gave up, right? Even though he failed calculus, which basically his theory of relativity was based upon essentially calculus, right? So all those derivatives that we're going over, that's how he arrived at this conclusion that basically time were really in 4 dimensions, right? So that's just to show you not to give up. Going through school, it's very difficult, right? You have to pay attention to everything, the fine print, the fine details, and you have to kind of perform. So don't give up, because even the greatest mind that's ever existed failed something, right? Anybody know who this is? Everybody should shout it out. George Washington. This is actually one of my heroes. I read one of his books when I was very, very small. He actually came up with over 200 uses for a peanut. Which to me, that's just amazing. Has anybody ever come up with 10 uses for a paperclip in there? 200 uses for a peanut. He's actually pretty close with Ford, Henry Ford, who created, basically throughout time, one of the largest automobile manufacturers. Part of his studies was actually taking the extract from the peanut and he actually synthesized a different rubber material. And that's one of the initial rubbers that they actually used for the tires for some of the Ford manufacturers. So, anybody notice anything about all these characters? The obvious?
They're dead?
Say what?
They're dead?
They all have gray hairs, right? So as you're going through your career, as you're going through life, you don't have to achieve your greatness at age 18. It's going to take you time, right? But you want to be on the track to get there, right? And so that's what throughout this discussion, I kind of want to, infuse that into your being, to know that you're on the right track. And I want you to stay on the right track. Also, this is Garrett Morgan, another inventor. He actually created one of the early renditions of the stoplight. So every time you stop at a stoplight, you should think of Garrett Morgan. Very influential behind that. So now I'm going to kind of get into manufacturing, and basically everything that we touch, everything that we create has been manufactured, right? Doesn't matter what it is, from your clothes to this clock up here to the carpet that you walk on every day, the tiles, such and such. But everything kind of follows really a traditional process, or it kind of follows the same process. We like to call it cradle to grave, is how we think of it. So it's more of the life cycle that you discover these materials and then we convert them into something. And then it becomes some different use in the future. So really everything is driven by ideas. Ideas is what drives us to solve different problems. Sometimes the problem is a humanitarian problem. Like now we have Ebola, right? So we have to solve that before it gets too widespread. Sometimes it's just a simple problem is, how do I keep this baby from teething too long, because, parents need to get their sleep right. I only say that because I have an 8-month-old and she's doing a lot of crying right now, so. So that we really follow this kind of traditional manufacturing process, and now we have concurrent engineering, so we look for opportunities to improve at all levels. So again, you have this raw material process where we take raw materials and we take them and manufacture them. And of course, like your iPhones, your Samsungs, then they get shipped to you. And that's how they interface with the regular customers. And then more importantly now is after these phones are done, right? Because they only last 2 to 3 years, right? And then we're done with them, right? What do we do with them after that? We just throw them in the garbage so we can poison our children 50 years down the road? No, so we need people to think of, well, how do I recycle all these materials that we're producing? Because eventually, right, this is planet Earth, so a lot of our resources are non-renewable, so we're gonna run out, right? So there's a lot of research, there's a lot of effort, a lot of dollars involved in people figuring out how do we take different materials and recycle them or either reuse them. So here, and since some of you in your, maybe doing some type of quality control class or SPC, here is what we call a batch curve. And basically you can see here that for any product, we usually have a certain number of failures that occur along its life cycle, so it's operational time. So usually there's something called infant mortality. So usually like when you get a cell phone or if you buy a car, usually when it comes off the line, you know, if it fails right then it probably, there was something with the process that actually created something that caused the failure itself. And then if it doesn't fail, you probably get to some time out of its use that it's actually operating pretty efficiently. And then usually at the end of its lifetime, then the probability of that item failing goes up, right? Because usually it's just at the end of its useful life, so it's aging. So we call this kind of the standard life cycle. So if you look at sort of this cycle, we call it again the birth to death cycle, so it's a cradle to grave. So you have your traditional processes where we have some type of research and development, right, where we take the materials again and try to come out with a new concept. And we go through product design, and we develop a process for it, and we actually manufacture it, and then do some process control to make sure we're manufacturing at a high quality. And then of course it ends its operational life cycle, and then at the end of that, then we either destroy it or try to reuse it as well. So you'll see that we have a few tools of the trade as far as being an industrial engineer and a manufacturing engineer to try to handle these problems. And here is just some of the different tools that we use. A lot of them, some of you engineers have heard as sort of lean manufacturing concepts. A lot of different other tools that you learn when you're going through college that you employ in the workplace, such as Six Sigma, also quality control, a lot of supply chain elements. So all these are basically to interface at each part of this whole life cycle concept. So we talk a lot about now about having a holistic approach to doing things and not just thinking of things in, or compartmentalizing things in one component, so we can take care of the whole life cycle system at one time. You can see here that the manufacturing engineer, the industrial engineer, actually interfaces at each part of the product life cycle here. And since I am an IE, I have to downplay mechanical engineers and civil engineers and all of those other engineers because they really don't have this interface along the life cycle of every single product. And we're not just talking about products, but you can also talk about systems in this way too. So the IE is very unique because we actually interface not only on the manufacturing side as even raw materials or design, but we actually interface with the business as well because Apple, right, has to generate so many iPhones, right, to be able to meet your needs, right? Everybody know who Tim Cook is, right? Okay, did you know he was an industrial engineer? No, he actually got a rose to the CEO because he used all these tools that I was talking about to make sure that every time they come out with a new iPhone that you get to meet your production schedule and you get to have that item in your hands, right? So, very important. So, what is industrial and manufacturing engineering? And here's just a world that kind of describes some of all the intricacies of it, anything from systems to designing operations. Of course, we're using mathematics and our science in the background behind all of this. So in the traditional sense, or more of a definitive definition, industrial engineering is concerned with the design, improvement, and installation of integrated systems of people, materials, equipment, and energy. And can anybody tell me why we mention energy here? Anybody? How about you, sir? Either one of you. Either you're grinning at me with a pretty ugly grin, so I'll call on you. Any reason why we mentioned energy? I told you I like to be interactive. Well, I mean, everything's energy, right? I mean, you're sitting in this building, you're burning lots and lots of power, right? So if I'm here manufacturing the iPhone, then I have to take account of how much energy I'm going to actually be using, because that's money, right? You have to pay for energy, right? So energy is not free. So that's very important. So it actually fits within this whole life cycle model, that everything sort of has to be maintained. So this is something that the IE keeps track of.